what we covered today in Info 3370, Studying Social Inequality with Data Science at Cornell. So it's January 27th, and today we learned how to use R for the first time. So before we all came to class, we followed the instructions in R for Data Science to install R and install RStudio, and then also install the tidyverse package. And so if you haven't done that yet, you should pause the video and go install those. And I'm making this video both for those who might want a recap of what we covered in class, and also folks who might be coming off the wait list and weren't there in class to see the material. Okay, so let's get started. So once you open R, this is what your window should look like. And you'll see that there are actually 4 panes that are likely to be visible in your RStudio platform. And so we're going to start with this pane at the bottom left, which is the console. And so the console is the place where you can interact with R using line-by-line commands. So for example, R can be a calculator for you, and you can type 1 plus 1 down here in the console, and then hit enter, and it'll run that command for you and return the value 2. So we talked in class about how using the console is often not the greatest idea because you are limited to one-line commands, and also because there's no record of what you did to produce your result. So more often, and I would say almost exclusively, we're going to use the source editor up here at the top to run commands. So here we can run that same command, 1 plus 1, and highlight that, and then hit Command Enter or Control Enter to run that command. You can also run it by clicking this Run button at the top. And now we see at the bottom of the screen that we now get the same command run down there. But the advantage of working in the source editor is that now we have a record of the lines of code that we use to produce the results that we might be reporting to people from our study. Okay, so that's a bit about using R as a calculator. When we work within the source editor, there's something that I do at the top of almost every R script, and that's load packages. So I'm going to put a note here and a comment. This little pound sign tells R that this line is a comment, and it can just ignore everything that comes in the line to follow. So then below that, in the next line, I'm going to load a package. So R is open source statistical software where there's a base set of functionality that comes in R as you have it, and then a lot of functionality comes when you load packages that users write and post for free on the internet following some standard conventions. And so R packages are really what makes this platform so great because there are new statistical methods that get developed and new data science approaches, and those often become carried out through packages that you can just get for free through easy commands. So before you came to class today, you ran the line install packages tidyverse. And so the tidyverse is a suite of software packages that have like a bunch of functionality that we're going to use very often during class while we work with R. And so once we've installed those packages, at the top of your code, you're going to call the library function. And when you type library, RStudio gives you some help. So it tells you that you can pass some arguments to the library function. And the first argument here is package. So this is the name of the package that we want to load into our R environment. So let's go ahead and run that line here. And you can see down here in the console that RStudio tells us that we now have the tidyverse package loaded. There was a question in class about whether we have to worry about these conflicts down here. So when you load a package, it's possible that there are other packages or base R functionalities that have the same names as functions within the loaded package. So for example, when you load R, you automatically have the stats package included, and that includes a filter function. And the tidyverse is actually a whole set of all these packages listed here. And one of those packages, the dplyr package, has its own filter function. And so R is warning you here that by loading the tidyverse package, you've masked that original filter function, so that now when I type filter in R, it's going to use the dplyr filter function, which we loaded as part of tidyverse. So because we're almost always going to work within tidyverse, I don't worry too much about these conflicts because I think of these functions as the ones that come from tidyverse as sort of my default functions that I'm going to use all the time in R. But this is one reason why the order that you load packages can matter, because the package you've loaded most recently might mask things from the previously loaded packages. Okay, so now we have tidyverse loaded. So the next thing we're going to do is load some data into R. And so in particular, I prepared a data set on median incomes in the United States. So these data come from the Current Population Survey, which is an annual study. They come from an extended part of the Current Population Survey, which is carried out every March to gather like economic and labor force indicators. And so what I've done is taken all households in the US and taken the median household when arranged by household income, and then recorded that household income for every year. So we're going to load this data into our environment by using the read CSV function. So this reads a comma separated values file, which is a file where there are, in this case, 2 columns, and there's a comma that separates which data correspond to each column. And so this line of code is going to do a couple things. It says I'm going to create a new object called median income, and I'm going to store something in that object. And what I store in that object is the output of this read CSV line, where read CSV is going to pull that data from the course website and bring it into our environment. So let's go ahead and run that line. So we run the line and we notice a few things have changed. So down here in the console, we see some information about these data that are now loaded into the environment. And up here in the environment pane in the top right, we now see that there is a median income object, which is in our R environment. And when we click this little arrow next to median income, we see that that object is a data frame that has 2 variables. So year is a numeric variable, and income is a numeric variable. So once I load a data frame, I often start by exploring the data a little bit. So I might want to know, like, how many rows are in the data frame? And here we see that there are 55 rows in this data frame. Maybe I want to know how many columns. And I can see that there. Or both, I might want to see the dimension of the data frame, which you can call with the dim command. So here these are all functions, and we're passing the median income data frame into those functions to learn something about that data frame. We can also look at the top of the data frame with the head function and the bottom with the tail function. And then finally, a particularly useful command, which applies to many R objects, is the summary function. So when we typed summary median income into R in class, we saw that it gives us the min, the first quartile, median, mean, third quartile, and max values of each variable in that data frame. So summary is a great place to start when you have an object in your R environment and you're not totally sure what might be in that object. Okay, a last point we discussed about working with data frames is that here each data frame has, in this case the data frame has 2 variables, year and income. And to extract one of those variables, we can use the $sign operator. So here we have the data frame median income, and we might want to look at median income $year. And so when we run this line, we here get to see all the data that are in the year column of the median income data frame. Okay, we're going to work often with data frames in class, but I want to talk a little bit about the other kinds of objects that can exist in R. So if you're familiar with another statistical package like Stata, you might be used to having all of the data be take up the entire environment. So when you load a data set into Stata, like the whole Stata space is all covered by that data set. But in R, we can actually have several objects exist in our environment at the same time. So for instance, I might create a new object called favorite number. And perhaps I want to store in that object my favorite number, which is 2. And I'm going to title this section Other R Objects. And so if I run this line of code, we now see that over in our global environment, we have 2 objects. We have the median income data frame, and we also have this new object, favorite number. And perhaps I also want my R to be able to say hello to me. So maybe I create an object called hi, and I want it to return. When I ask for hi, I want it to say, hi, Ian. And so here now I've created another object. So now we have 3 objects in our global environment. And here if I go in the console and I say hi to R, it will tell me back, hi, Ian. When working with objects, you can learn some about them by looking at their class. So every object in your R environment has a class, And so for instance, if we look at class of favorite number, it'll tell us like what kind of thing this object is. In this case, it's a numeric value. And we can also do class high and see that that's a character value. And finally, we can do class median income. Now, median income, because it's a data frame, is more complicated. So it's not only a data frame, as you see at the far right here, but it's a special kind of data frame known as a tibble. And tibbles are a special class of objects created by the tibble package, which is part of the tidyverse. So we're always going to have it automatically in R once we say library tidyverse. And you can read in the documentation page about tibbles and how they might be good and how they're different from data frames. In general, in this class, we'll just be working with tibbles. Okay, so those are objects and those are classes. The next thing I want to discuss is making a visualization. So a key tool that we're going to use in this class is the ggplot function. So ggplot is a package designed for data visualization. And it's created by Hadley Wickham. You can see all the developers over here. And it's a core part of the tidyverse. So at the ggplot webpage, you can see lots of information about ggplot, including examples of how it can be used and what you might do to get to learn it. And I want to draw your attention particularly to this cheat sheet, which gives you like a quick resource for information about how to use ggplot. And much of what we're about to discuss also corresponds to Chapter 3 of the textbook, R for Data Science by Hadley Wickham. And this is the assigned reading that goes with class for today and the coming Monday. And you'll see in this chapter there's lots of information about like what a data frame is and how you would go about creating a ggplot. So I would recommend you look at really chapters 1, 2, and 3 of R for Data Science after class today. Okay, so how do we use ggplot? When we use the ggplot function, RStudio tells us there's a few arguments that we might use. And particularly, it's important that we hand a data argument and a mapping argument to ggplot. So the data argument tells it what data frame to look in for the data that are going to be plotted. So in this case, we're going to use the data frame median income. Then the mapping argument tells it what variables in that data frame play various roles in the plot. So in this case, we have x equals year and y equals income. And when we run this line, now in the bottom right panel of RStudio, we see a basic plot here, which is like an empty canvas that we can now add things to in our ggplot. So one of the first things we're going to add is some points. So we're going to take every data point and make it a point on this plot using the geom_point function. And here I'm linking various ggplot commands across different lines using this plus operator, which is an operator that's special to the ggplot package. Okay, so once we do geom_point, we now can see how the median household income in the US has changed over time. Geoms are really important in ggplot because you can add lots of different geoms to do different things. So for example, we talked about how you can use geom_line to create a plot where those points are connected, or you can use geom_smooth to create a plot that shows a curve that smooths over those points and also includes a confidence interval. So there are many geoms that you might use, and you can Google to find lots of options about things that could possibly go into the plot. Given this plot, we then talked a little bit about what we might do to make the plot better. So something we first talked about was adding a title. So perhaps we want to add a title here that says we're going to look at median income versus year, or we might say even more expansively, median incomes across years in the US. And so that now appears at the top of our plot. And perhaps we even want to add a subtitle that gives even more information. For instance, we might say in a sentence what the plot shows, which is that median household incomes rose over time in the US. And so now when we run that, we have our title and our subtitle there. We also talked about adding labels on the X and Y axes. So we talked about the simplest way. This xlab command will let you just rename the title that appears on the x-axis, and ylab will let you rename the title that appears on the y-axis. So perhaps on the y-axis we want median income across US households in 2022 US dollars. Great. And so you might look at this and say, wow, that's really a long label on the y-axis. So we didn't cover this in class, but you can use this /n command, which is a special character that will put a line break in that title, which is often helpful if you have like super long titles that are going on there. So then in class, we talked about what else we might do to make the plot even better. And there were some suggestions about how we might change the tick values on the x and the y axis. So the first suggestion was that perhaps instead of just the years 1980, 2000, 2020, we might want to have more years labeled along the x-axis. So instead of using the xlab command, we can use scale x continuous, which is a more extensive command that lets us modify lots of things about how the x-axis appears in ggplot. So the first argument we might use with scale x continuous is name. So here we're going to keep the name year. Then we might want to modify the places where there are ticks along that axis. So to see what you can do, you can always look at a help file. So here down in the console, I'm writing question mark and then the name of the function, scale x continuous. And now we get to see in the help file, like lots of things that we can put into this argument to change our ggplot scale. So the one we're going to work on today is breaks, which is here. So you see that in the argument here, and you can see it down here in a little description of what you can put in. So for the breaks argument, you can put various things, including a vector of positions or a function that returns breaks to include. And so there's lots of examples here, and down at the bottom you can see some code that will use the arguments illustrated above in the help file in the code. So the help files are super important in ggplot and in R in general, and you can always use question mark function to get to a help file. So in this case, let's go back to our plot here. We were going to set the breaks to be a series of points from 1970, 1980, 1990. And so here the C function, which also has a help file, will combine values into a vector. And so here we have these values for all the breaks we want, and we're just going to make them into one vector. And if we highlight those values, we can see that vector down here in our console. So back to the plot, we can now run this and see that now we've got those x-axis values. Now you might think this is quite cumbersome, how we've written out every year value. So another way to do this is with the sequence function. Let's erase what's inside here, and let's look at the help file for seq. So sequence takes some arguments from, to, and by are the ones that we're going to use here. So in this case, we're going to have a sequence from 1970 to 2020 by increments of 10 years. And when we run just that sequence function, we see all the values down here. And when we run our code, we see that we have our plot with that sequence of values that we wanted. So then there was a last suggestion in class about how we might improve the y-axis even further. So perhaps instead of ylab, we're going to now switch to the more expansive option, scale y continuous, which is just like scale x continuous. And it's going to have a name here. So if we run that, we'll see that we again get our same plot again. And there was a question about how can we make these labels on the y-axis use dollar signs to clarify the units instead of just being a number. So to modify the labels, one thing we can do is to have the labels argument here. And when we look at the documentation for scale y continuous, we can see that there is the labels argument here. And labels can take various things And what we're going to use here is a function that takes breaks as inputs and returns labels as output. And so this is going to be a function that takes these values as the input, 60,000, 65,000, up to 80,000, and returns $60,000, $65,000, etc. And so this function actually exists in the scales package in R. So if I do question scales, you can see that this is a new package that we don't have loaded as part of tidyverse. And so this is a useful thing for modifying the scales of a package. So let's go ahead and load the scales package up here. Okay, and to load the scales package, you might have to first install it if you hadn't installed it yet. Okay, so within the scales package, there is a function called $format. Okay, and look at this. It's actually superseded to label $. I didn't know this when I started working on this problem. So let's see what happens with the label $. Function. Okay, so this is a function to label currencies. And so it takes as an input some numbers and it formats them as currencies. So let's see what happens when we hand this function into our labels. So here we have labels equals label $. And look at that, it works. So now we have on the y-axis those numeric values, and also we have them as labels. We could also have done this manually to modify our axes. So we could have done custom label $. Is going to be a function of an input x. This is, I should say, this is an advanced topic we'll get to more later in the semester, where it could take as an argument x, like some value here, and we want it to return a formatted version of x. So we could use the paste0 function, which collapses a couple things together. We could say we want a $sign, and then we want x. And we might also not just want x, we might want pretty num x. Okay, and pretty num is a function I use a lot, but clearly I have forgotten that there's this argument big mark that we want. And we want the big mark to be a comma. Okay, let's try that again here. Custom label $80,000, and we see that that gives us $80,000. So if we had done that, you see how with this function we could have our own custom labeling function. Custom label $. As you see, I sometimes forget how to put arguments into ggplot myself. Okay, there we go. So the name of the function here is going into the labeler, and we get the same output as we had from using the canned one. But since that canned one exists, we don't even really need this custom thing. We could just use the label $. Okay, so the very last idea we discussed in class was about changing the theme of the ggplot. So if I go to the ggplot theme reference, you can see that there are many ways a ggplot can look. So it can have this gray background, this white background. You can have it with like no grid lines, no lines at all. There's a lot of options. So this is one way to easily customize your ggplot, where you can just add a line theme BW, and now we have a black and white plot, or theme void, and now we have a plot with like no axes at all, which generally I would not encourage. So maybe I'll stick with theme BW because that's one that I use a lot. There, and now we have our plot. So I feel like we covered a lot of material today. We covered how to load a data frame in R. We covered how there are these various R objects that can exist in your global environment. We covered how to load packages at the top of your R code. And then we covered some ways to use ggplot to make a plot, where we start out with this main call to ggplot, which sets up the environment, and then we can add geomes to that call to add points, maybe add a smooth. Then we added titles and axis labels to produce a plot that is informative and useful. So that's it for today. If you have questions using R, then definitely post them on Ed, and look forward to digging more into what we can do with R visualizations on Monday.